Thanks so much for joining us tonight. We're super excited to have an in-person special of the Generative AI and AWS meetup. For those of you who are a regular follower of the meetup, know that we usually do those online on Mondays, every third Monday of the month. Super excited that we do have the chance to do an in-person meetup tonight, thanks to AWS hosting us. It might sound a little weird to you. I'm wearing two hats tonight. Antje, Barth, Principal Developer Advocate at AWS, so I do work at AWS. I'm also running this meetup group together with my friend, Chris Freckley. Chris cannot be here tonight, sends his regards. So I'm here tonight primarily as the host of the meetup, so that's why my thanks go to AWS for hosting us. It's a little speaking in the third person here. And thanks to all of you joining us here. So some of you might have found us on Luma as well, where we also advertise the meetup. So for those of you who are not familiar, this is the meetup group, primarily on meetup.com, where we host our monthly online meetup. So if you want to follow us afterwards, if you're not already doing that, I think we're roughly around 15,000 for the San Francisco chapter. We do have a couple of other groups worldwide too. As it's online, it's usually a little bit more accessible for folks if you just want to dial in. We're also posting sometimes, if we have the opportunity, partnering with conferences here in San Francisco, to post some discount codes. So we have a little partnership with conferences sometimes going on as well, and we can offer you a little bit, off the ticket price there. So there's a couple of events coming up in San Francisco, so you might want to check this out. And we do have our regular next month, September online meetup, where we're going to talk about a lot of exciting things, including more multimodal topics. A little background for this meetup, we're trying to record everything. So we're also recording tonight, if you saw the Zoom earlier here on the screen. So hopefully if that works out with the audio, we're going to post that on our YouTube channel. You can visit that. There's a recording of all the previous meetups as well. If you want to follow up on the topics or rewatch some of the meetups when you weren't able to attend. Chris and I, together with another colleague, Shelby, we also wrote a book, Generative AI on AWS. We're not very creative with the main characters and same, but I think it also helps for you all finding content. So there's a book available, and we also do have a GitHub repo where we keep publishing a lot of cool code examples as well as the space moves really fast. Okay, that's a little bit about the community we have, if you want to follow us there. And super excited, I just created this page on Luma as well. Luma is more focused on the in-person events, so this is the first one tonight I posted there. But if we have more opportunities to bring you all together here in the city, we're gonna definitely put that on our Luma site as well. All right, yeah, I said already, thanks to AWS for hosting us. Hope you also enjoyed a little bit of the networking before, the snacks out there. Quick call out, we also do have members from my team here. We have the developer experience team. Also, our VP Adam is here. You might have seen him on other meetups and events here in the loft as well. And the rest of my team, if you can just maybe show hands a little bit, if you want to connect with us afterwards. A couple of you are speaking tonight as well. So we're super happy to have you. Also, if you noticed the loft space here, there's a lot of things going on right now. We are reopening and have reopened the loft here to be really kind of a hub for you all, for the community, the AI engineering community, to come together, attend workshops, host your own meetups. So make sure you're checking your badge on the back, it has a QR code. If you scan that, it takes you to the loft side. We have a GenAI pop-up loft going on right now. So the next couple of weeks, there will be events happening here. You can find the latest. If you scan the code, go to the side. We keep adding events. So even if you just see maybe a couple of events right now, keep checking because we're adding them as we go. So make sure you're checking for more events on here. One event I also want to call out is we have another event hosted by my team this week on Thursday with my colleague Mike and Banjo, who are here tonight as well. They gonna switch a little bit the topics and talk about some fun stuff in the gaming world. So you will have an intersection there of agents that suddenly, I think, start to start a brawl there or do some Minecraft action. So if you're interested in that and just want to have a good night on Thursday, definitely come back here for that event. It's listed on the site, so if you scan your QR code, you'll find all details where to sign up. All right, that's enough for a little bit the housekeeping. Let's come back to today's agenda. We have an exciting lineup hopefully for you with a lot of different topics. I think there's a general theme tonight of multimodality and some alarm sounds. I'm going to start just briefly with an intro of what happened in the space in multimodality. And then we do have a special guest here who I think just arrived. There he is, Felix. Felix is joining us from Meta Reality Labs. So I'm super, super excited to have him tonight. And Felix is going to talk about creating extended reality XR applications on web. So very curious to hear more. We have Mike from my team who will talk about AI running its own code, specifically around what is an agentic code interpreter and how can it help us build cool things with AI. And then also we have Danilo visiting us, and he will present how to bring all of those components together and will show us a multimodal chat interface that pulls together some storage, compute, web access, and really helps us to bring this beyond text. So a lot of different topics, I think hopefully something for everyone here in the audience. And with that, did I miss anything for the housekeeping? I think we're good. All right. I know my team was super, super curious if we can get a selfie from the whole room here. If you want to try this real quick, I think now is the time. If you want to squeeze up here and try to get one of those fancy selfies, I think it's a kind of a competition sometimes. Can Oprah do the better one or?
Hi. It's selfie time.
All right. Where's the rest of my team disappeared? Sorry.
A team of shy people.
Okay, how do we do this with the room here?
As wide as you can, because the room
I know, I'm trying. It's faster.
We could all do one, couldn't
You gotta do that. All right. Okay, we tried our best. You'll find that on Twitter and LinkedIn. Follow us. Okay, that doesn't work. I don't know what works. All right. Without further ado, let's get started with the talks for tonight. So I'm gonna walk you a little bit through what happened in the space of multimodality. And there's a lot going on. This slide doesn't claim to be, the full picture. It's just a couple of highlights that I put together that shows a little bit of what's happening in the different areas of multimodality as well. So many of us probably have heard about CLIP, got released by OpenAI back in 2021. CLIP is still up to this day a big component in multimodal applications and architectures. CLIP was really kind of the first one that brought together image and text and combined the two in an embedding space in a way that you can have a model that's really great at classifying images in a zero-shot capability. So it learned to correlate the text, a description, and the picture. So you can use that later and just show a picture and it's able to say, yeah, this is a dog doing something, right? So really, really kind of the first ones, breakthroughs that combined image and textual information. Then in 2022, throughout the year, we saw this emergence of diffusion transformers. And diffusion transformers was also kind of revolutionary, presented by researchers from UC Berkeley and New York University in a way that they revolutionized the architecture of the unit architecture that was around in diffusion models by adding transformers to it. And this really helped to kind of increase the quality of the image generation. And diffusion transformers are still pretty popular up to this day. Then in 2023, in April, Meta came out with a segment anything model, short SAM, the first generation. And this is what I'm going to show you. That's why it's in red here, the two SAM models, because I think it's really amazing what Meta did here with those models, specifically how to do image segmentation. And then with the latest one, which just came out in July this year, that can also do segmentation in video frames. Super exciting. In between, we had also different aspects of multimodality. There was LLaVA by Microsoft, Large Language and Vision Assistant, which was and is special in its way that it's applied instruction fine-tuning to the world of multimodality. And now you can give images and the model is able to understand the image and give you a description. For example, if you pass an image with people around a car trying to stuff luggage in the trunk, you can ask what's happening. And the model is able to understand and not just describe the objects in the picture, but says, if you ask like, what challenge are they facing? That it knows, oh, they're struggling getting all the luggage in the car and stuff. So there's all those different aspects, like how to work across modalities and things you can build. I also want to call out, Meta has been busy here releasing ImageBind in May 2023. ImageBind, if you haven't heard about that, I recommend check it out. It's across modalities, so text, image, audio, and a couple more. And it's combining all those modalities in a single embedding space, which is super exciting if you want to go from one modality to the other, if you're doing, multimodal retrieval. For example, imagine you're giving the model an audio file of the ocean, right? And then the model is capable, for example, to pull images of the ocean by associating the audio across a modality to a picture. So there's really amazing stuff you can do in this space. And then Amazon entered multimodality as well. So in November 2023, Amazon released its own model, Titan Image Generator, together with a multimodal embeddings model. And if you haven't tried it out, definitely give it a try. Image Generator embeds a lot of really cool functionality directly in the model. You can give it reference images, and it helps without the fine-tuning really kind of keep an object in the generation that's similar to the reference image. It can help you in the latest revision. We just released version 2 of this model to remove backgrounds by prompting it to do so. So a lot of things that required a lot of extra tasks or coding in the past is already built in this model. So also really cool. Chameleon, also by Meta, Meta has been busy, is interesting that it processes image and text, like we've heard a couple of different use cases, but it also outputs the two. So usually you have like image text and output is text, like describing an image, what's happening there. Chameleon can also create visual. So this is an exciting use case, for example, in education. Let's say you describe that you want to like create a short course for students about, let's say, how tornadoes are formed. I just saw a Twisters movie. That came to my mind. And then Chameleon could do like the reasoning and create like, the lecture content type of textual output, but could also say, if you tell it like create some visuals along, then explain the context, atmospheric concept, etc. So you can also create the images according to that. So it's also kind of, instead of just image text input, it can create both as outputs, which is a different architecture for the models to do that as well. And then SAM 2 just got released, so Segment Anything 2. And I just want to have a quick walkthrough here because I really found that super, super interesting. So let's have a look at SAM 1 that came out. The SAM model and the Meta team, they came up with a new task to train the model, and it's called promptable segmentation. What that means is you can very easily, with simple, flexible prompts that are shown here in the pictures, that could be just a point or boxes, create those segments, the masking here in the image. The model is transformer-based. It's trained on a large data set. And it is really, really cool in zero shot and real time. So I'm going to show you the demo in a bit here too. That means you can literally just create a point and it predicts the correct mask. And for those of you who have been in this space for a longer time, they probably know how painful it was in the past to create like masks and segmentation in images. So this is super cool. Really quick on the architecture, is based on a vision transformer encoder, and it runs once per image and then outputs the image embedding. And then there's a prompt encoder in this architecture as well, which embeds your input prompt, which is, the click, the point, or the box. And then there is a decoder part that then predicts the mask. Use cases, you can imagine anything from content creation and editing, where you need to segment objects in real time, in the medical space, medical imaging, or something in robotics, where you need, flexible segmentation as well. But I really want to get to this demo here real quick, because seeing is much cooler than just talking about it. So all of this is online hosted, so you can also try this out after the meetup. And here's the library, and I just grab, I think cats are always fun. So here I am, it's the image, and you can, if I zoom in here a little bit more, if that works. You can just literally click here, and it predicts the correct mask, right, of the cat. You can add a second cat to it if you like. And you can see the accuracy is really cool, right? How to create those masks in real time. You could also say everything. So now you see this overlay here with those points, and what the model is doing, it tries to really create a segment for everything you see here in this image, right? So anything in the background, the cats, of course. And this is super fast, right? And is really cool. You can draw boxes as well. But they didn't stop there. So going back here, what just came out, which really is exciting to me, is the Segment Anything Model 2, which took this from the image space to also process videos. And some of you might have seen Mark Zuckerberg's demo of this. I think he presented it at a couple of events. It is really, really impressive. So here with SAM2, Meta introduced the new task, promptable visual segmentation, called PVS. And it handles both images and the videos, and it's able to tackle the object across the different frames, right? So you're going to segment, and we're going to see this in a bit as well. The way they did this to keep the context of an object across the frames in the video is by adding memory to it. So they added a component, streaming memory, here that is able to maintain this context. Also, if like an object disappears from the video sequence, right? Maybe the cat is running outside of the video and at a later point coming back in and is visible. So with the streaming memory, it's able to connect and remember and say, oh yeah, here's my object coming back in. Another thing that's really kind of nice is the data set. So Meta released the data set. They put together a large scale data set, I think one of the biggest in existence right now for segmentation. And it's trained on both image data and then on video as well. So here's the updated model architecture. So it built on the first generation of SAM, but it added a couple of things. So the streaming memory that I mentioned, it's using a transformer-based hierarchical masked autoencoder, HERA. Not going to go in all of those details. And it's really unifying the image and video segmentation here. So really exciting. If you want to read more about this in the research papers, it's a cool thing. But again, demos are saying a lot more, so I'm going to try it out here. All right, and it just loaded here a sample video. And what I can do now is, let's track the soccer ball and maybe the shoes, right? And then I can do here track object, and you can see now in the video clip how it correctly segments the shoes, the soccer ball, and it keeps track of it across the video. So this is really exciting. They have a couple of more videos here where you can just see how it works. I'm always excited about this octopus here because I think it's just a really hard thing in water with all the reflections. So if you segment here this octopus, and I'm just clicking on it, right? That's the only input prompt I'm giving it, my click from the mouse here. And then I say track it, and you can see how it's, even with a movement, think it's not that easy like a soccer ball, right? It looks pretty amazing. Those models are, by the way, I learned hosted on Amazon SageMaker. All right. So that's a little bit about the intro here. Again, the data set, the SAV data set, Meta released it. It contains over 50,000 videos with over 640,000 masklets. One of the largest ones, if not the largest one right now in existence. So this is really cool. The way they created this data set was kind of also a mixed approach. They used, they created this data engine where they started with annotated data. They pre-trained first on the images from the previous model, from the SA1B data set that they created for SAM1, and then fine-tuned it on the video data. Data set is available, and performance and applications, just a couple of last words. It's really, truly cool to see the real-time processing power here, 44 frames per second. So perfect for live applications, great in benchmarks. Key applications here I want to call out as well. Obviously, medical imaging. I think that's a pretty big use case in general for image segmentation, video segmentation, autonomous vehicles, video editing, and also mixed reality. And this is a great segue, I think, into our next talk, welcoming Meta on stage. SAM2, by the way, is available under Apache 2.0 license. You can check it out on GitHub. And with that, I'm introducing Felix from Meta, and he will talk through creating extended reality applications on the web. Thank you. And just a quick moment while we set him up. You can use your computer, yeah. Did you get the Zoom link?
I don't think I have.
Okay, and the invite? If you have a chance to join because we're recording.
Yeah.
You have the calendar invite.
Calendar invite? Oh, okay. So,
One I sent you, yeah, to scroll. Yeah,
I think
if you
this
click
is
it
the one.
open, yeah.
one?
There's the Zoom link in here, yeah, just got a little smashed. Zoom link.
Yeah, yeah.
Can you-
I think
can you
this
open
is
it?
okay, yeah.
Oh yeah, it was clickable.
It's a little bit.
Recording in progress.
Okay, I'll make you panelist. Okay, and if you can unmute if you're recording and do a screen share if you want to plug in.
Sure. Sure.
Yep, I see yours. Off the mic. Take it away.
Hello, everybody. My name is Felix. I'm a software engineer at Meta Reality Labs. I work on everything WebXR. Very happy to be here today. Yeah,
Just turn the volume down.
I already did.
Try again.
Hello, hello. Oh, maybe this is the thing.
No, is it mine?
Hello, test. Oh, is this better? Okay, sorry about that. Minor technical difficulty. Yeah, so like I said, I'm a software engineer at Meta Reality Labs, working on the MR Web Platform team, which is the team behind the browser in Meta Quest devices. And I'm very happy to be here today talking about building XR applications on the web. So before we start, can I get a quick show of hands? How many people are familiar with the concept of XR, you know, AR, VR. Okay, most people here, that's fantastic. And how many people are familiar with WebXR? Okay, we have yeah, that's nice. We have a decent amount of people. Thank you very much. So yeah, for people who are not familiar with WebXR, it is a set of device APIs that allows web applications to interface with the XR hardware. So think, well, let's take native apps, for example, since most people here are familiar with XR. One of my favorite games is Beat Saber. So a Beat Saber is Unity. You built in a game engine like Unity. How does the app talk to the device to be able to get like headset transformations and controllers? Well, you do that through OpenXR as a middle layer so that the app can communicate with the XR hardware, right? Same thing is WebXR. So basically, WebXR is the middle layer that offers the API for web applications to talk to the XR headsets. And whoops, already played. So here's a few examples of notable WebXR experiences. On the very left, we have Project Flowerbed, which is a project that I actually worked on as part of my job at Meta. It's like a Zen garden experience. You can go and plant some flowers and take photos and just walk around. It's pretty cool. If you want to check it out, it's Meta Demo Lab, flowerbed.metademolab.com. The second one here, this is actually my favorite WebXR experience of all time. The Escape Artist. It just won a Webby this year, by the way. It's a fantastic escape room experience. You should totally check it out. It's also free, by the way, I forgot to mention. The third one, Elysian, is a wave shooter experience. I actually built that one myself. I have a game studio, Elixir Games. And this is a single player wave shooter. It started out as a single player wave shooter experience, and then we added multiplayer support to it, and it's a ton of fun. And all of these experiences are featured on the new tab page of the MetaQuest browser. You have a MetaQuest device, go into the browser, fire up the new tab page, and you will see those in a hero banner. So yeah, please go check them out. And this is WebXR today. Like WebXR today, as most XR applications today are mostly games and entertainment focused. But you know, with MetaQuest 3 bringing the mixed reality capability to the masses, we're seeing some really interesting ideas from the developer community. And so we have some additional footages here showing some interesting use cases that we're hoping to see really soon from big enterprises and startups. So on the very left, we have Real Measure, which is an example of using your controllers in mixed reality to measure real life things. It's not super accurate, but like it's for something like shopping for furniture or something like that, it's perfectly fine. The second one is exactly a shopping for furniture experience. So you can select from a catalog of 3D models and you can place them in your room. And the third one is a prototype we built for e-commerce, specifically shopping for shoes. It's able to allow you to configure your favorite shoes, and you can even put it on the ground to try it on for size. Yeah, so those are e-commerce applications, but that's not the end of it. We see a lot of potential for WebXR in different areas such as education and real estate. Matterport, for example, is a very good example. I think if you went house hunting in the past couple of years, you've probably seen Matterport before. If you do that in a headset, you actually can enter WebXR to see the house from the inside. Cool. So now that you mostly have an idea of what WebXR is and WebXR can do, why would you build something with WebXR? Why not use native? Why not use Unity and Unreal, right? So there are several aspects to this. I think the first one is easy deployment and updates, because WebXR experience is essentially just the web page. So there's no install required. You basically just if you are in a WebXR enabled browser, such as the MetaQuest browser in MetaQuest, just go ahead and jump to that particular link and hit enter VR, and you're there. There's no install required, no waiting around for downloads, nothing. Second one is kind of also related to this, quick iteration, right? Like, so think about if you build an app and you ship it through a store like the Quest store, you go through a process, you know, like you have to go through reviews and you have to wait for the users to actually download the update. But with WebXR, it's completely it's completely on the server side. So you just push the latest version of your app to your web server, and the next time players, the users come to your website, they're always going to be on the latest version. So quick iteration as well. The second aspect of this is accessible and scalable platform. First of all, there's a lot of web developers in the world, and the community, the projects coming out from the community are just amazing. So, you know, you have a lot of people who are already, you know, like familiar with part of the technology. And secondly, you can tap into a lot of the existing web ecosystem, frameworks, library, and such, everything. When you're developing a WebXR experience, directly drop those into your project and you're good to go. And the final aspect that I think is also pretty interesting is cross-platform by nature. Because it's just a web page, you know, it doesn't take a lot of effort to actually convert your 3D experiences on a 2D screen into WebXR, right? All you need to do is to strap the camera to your face and adding some interactions with your controllers, and you're good to go. And it's the same the other way around too. So I built my game Elysian as a WebXR experience first. And then once we started to think about scaling this experience, like, wait, we have a lot more people on you know, laptop and mobile. How do we cater to that audience? Well, it turns out it's very easy. And I'll go into the detail of how I did that with a particular tool later in this presentation. But yeah, like once you have the camera and the controllers, you can pretty much just fix the controllers in front of your camera and move them with your camera. And you have a functioning 3D experience on your laptop screen or mobile. I mean, mobile probably takes an extra step. You probably need to add some buttons on the screen to be able to control the camera. But yeah, but it's very easy to do. So after the pitch for WebXR, let's dive deep into what specifically WebXR can do. There is the immersive foundation stuff, which is, you know, being able to get the headset transform, get the controller transform, being able to render immersive content for the user. Everything you can expect from a native XR application as well. The second one is versatile inputs. And by that, I mean, we obviously have the controllers. We also have hand tracking is also a feature supported by the MetaQuest devices. And we also surface that to WebXR experiences using the WebXR device API. And number three, we have contextual awareness. It's kind of a big word. Specifically, it's mixed reality capabilities. So for people who tried mixed reality in MetaQuest, you know, when you put on the MetaQuest 3 headset, you already see the surrounding in you with the pass-through video layer. So that's one aspect of it. The second aspect of it is that it has APIs to allow you to get, not you, but like your application to have more insight in the physical surrounding of your environment. For example, plane detection would be a good example. It tells you where the planes are in this room. You have, for example, in this room, we have floor, wall, window, ceiling, and well, I have a podium, so it's kind of a desk in front of me as well. Those you will be able to do with plane detection. We also have mesh detection, so it would be able to give you bounding boxes of furniture in your house. Say I have a couch here, TV there. TV is kind of interesting because it's a plane, but it also has some thickness. So yeah, you'll be able to get both of those information with the plane detection and mesh detection API. I think like I set it up in my house and I was able to get like my wall art as well. So it's able to tell a lot of things for you. Cool. So with that, let's take a look at engines and frameworks. If you want to build a WebXR experiences, what are your options? So on the native side of things, we've got Unity, Unreal. On the WebXR side of things, it's a very nuanced community. So we have some pretty interesting options here. On the bottom left, we have Three.js, which is the most popular 3D library on the web today. Just period, not for WebXR, just for the web, period. If you've gone on some e-commerce website that has like product configuration or product visualizer, the chances are that they're using Three.js. In the middle on top, we have Babylon.js, which is another very powerful 3D library. This one is actually backed by Microsoft. It's a more of a opinionated 3D library, does a lot of things for you. And it also, if I'm not wrong, I think it has Havoc physics engine integration, so you can do some pretty crazy stuff with it. It's very cool. Directly down below, we have A-Frame, which is a framework that's based on Three.js, but allows you to do things the declarative way. What that means is that basically allows you to create your XR scene with just HTML. The framework will parse the HTML for you and create a scene. Very similar to A-Frame, we have React 3XR, also does things the declarative way, the React way. This one is going to be super interesting for React developers because it taps into React and uses the React way to manage component life cycles and abstracts away a lot of the complexity with computer graphics and just 3D in general. So it will be a very easy time for React developers to onboard to that. And finally, we have Wonderland Engine, which is people coming from Unity or Unreal might really be interested in this because this offers an IDE, fully functional IDE, just like Unity. And you can expect a lot of bells and whistles that you can expect from Unity to this as well. It just exports and builds to WebXR. Cool. And with that said, let's take a look at some of the developer tooling that we've worked on. The first one is Immersive Web Emulator. This is a browser extension that basically allows a WebXR developer to be able to run and test WebXR applications on your desktop browsers without the need of a physical headset. And how it's able to do that, it's that it injects a polyfill layer that supports all of the WebXR APIs directly into your web page before your page loads. And what this does is that it's tricking the web page into thinking, hey, I'm actually running on an XR-enabled device, and it will be just able to render normally, like you can see in the video. And after that, it's able to create, like in the Chrome DevTool panel, it's able to create a interface to surface those controls. So you'll be able to control the emulated joysticks, your controller buttons, and you can move your headset and controller transform in there as well. So it's got 6 degrees of freedom emulated transform control for headsets and controllers that we just talked about. It also boasts a comprehensive controller input emulation with keyboard mapping. So I think at some point in this video, I was not using my mouse cursor to control this particular interface, but I was using WASD which is mapped to the joystick. So I can just run through this experience as if I'm playing on PC. On the mixed reality side of things, we have synthetic environment, kind of a abstract name, but what that means is that you're going to be able to build a virtual environment that basically it emulates your real world room. So in this case, you will see that there's a grid background in both of the left and right side of the panel. Those are actually not rendered by the application. Those are injected by the emulator into the experience as a pass-through emulation. So those basically will imagine that as your real room, basically. And we have customizable room dimensions. So you will be able to change the room's dimension, and you can create different objects in your synthetic environment that will show up on your application in real time. With this, when you create something in your synthetic environment, like you place a desk or put a wall here, those are going to be translated into XR planes and XR meshes and provided to your web application in real time. I think you saw a little bit of that just now, but over here, I'm going to create a desk as well as a monitor, and I'm going to move it up, and you will see that. So this is kind of interesting. So if you look at the left part, the blue block is actually rendered in the pass-through by the emulator, while the wireframe is actually rendered by the app. So you can see that they match up perfectly, and everything's happening in real time. Next up, we have emulated hand tracking. As I mentioned earlier, hand tracking is a feature available for WebXR applications. And we've enabled support for emulated hand tracking in the emulator as well. So we have a bunch of built-in poses. I think we have a relaxed hand pose and a pointing pose. Also, we support the pinch gesture, which is kind of universal interaction for using hands right now in the industry. We can morph to that, whatever pose you have, we can morph to that pinch gesture from that particular pose. And this video shows them using this to push a button in a WebXR experience. And finally, we have hit tests and anchors. Anchors are an interesting concept. So basically, when we have a spatial anchor, we use spatial anchor to improve tracking accuracy when you have a larger room, and the emulator is able to support this as well. Hit test is kind of a more convenient but less capable feature than plane and mesh detection. What it does is that you're saying, hey, I just want to know if I cast the ray from this point in this direction, I wanted to know where this virtual ray will hit my real room. And hit test is going to be able to give you that. So you can do pretty much the same thing by getting the actual plane and the mesh and do the ray casting in your applications. But this is a more convenient way to do that if you don't need that extra information. Cool. And after this, we have Immersive Web Emulation Runtime, which is quite similar to Immersive Web Emulator, but this one is not a browser extension. This is actually the core of the Immersive Web Emulator. It is basically the same. It's the runtime that supports all the WebXR APIs, but it's in the form of a library, so you can feel free to drop it into your WebXR experiences, and you will have an XR device interface that you can use to control the emulated device. One thing you can do is to build a bespoke WebXR developer tools. Why would you not use the Immersive Web Emulator and build your own tools, you might ask? Well, because in XR, interactions are incredibly nuanced, and like building a shooter experience versus building something like Beat Saber required completely different tooling. I can't just strap my controllers in front of my face and try to slash the cubes like I can in XR. So you might need some specialized setup, and there's no good answer that can fit all of the projects. So having this in the form of a library that you can use in your own projects give you that flexibility to build the thing that can accelerate your development. Next up is cross-platform controls. If you've taken that step before, building your bespoke dev tool to enable your WebXR experience to run on PC, where I assume most of your development happens, then you are not far away from achieving this, because you can just figure out a nicer way, add polish here and there, and just bring cross-platform controls to your WebXR experience. If you build a WebXR experience, you want to make it work on PC, make it work on mobile. Yeah, you just have to make some UI changes and figure out a good keyboard mapping. And that's pretty much it. Everything made possible by Immersive Web Emulation Runtime. you can check out flowerbed.metademolab.com. That's the same URL for both the XR version as well as the PC version. So whatever the platform you are on, just go check that out and you'll be able to get what I mean. And finally, we have input recording and playback, which is a pretty highly requested feature in the XR developer community for the longest time. People run into different kind of bugs and crashes in their applications all the time. And it'd be nice to actually get an actual capture that you can play back on another device, a more developer-friendly device, and be able to robustly repro what was going wrong. And so you can have an easier time troubleshooting this particular issue. And this will allow you to do that. So you can take this library ships with a capture agent that you can drop into your WebXR experience. You can capture a sequence of input events and later have it play on a PC or a mobile device with immersive web emulation runtime. And this is actually a video of like, I captured this particular input session on my headset, and this is actually this playing on a PC where I made a screen recording. You can see I switched from controllers to hands as well. Yeah, so that's all I have. We have some time for a few minutes for Q&A, maybe?
We do.
Yeah, cool, thank you.
Thanks so much, Felix. Really,
Thank you.
really appreciate you giving us this intro into XR. All right, we do have time for questions. Just raise your hand. Oh, many hands. Okay, let's start here.
Hi, thank you. That was like really cool presentation. My question was like, you mentioned about cross-platform, right?
Yep.
Does it mean like with vertical and horizontal, it can like just transfer like automatically, or you still have to design for like vertical look and horizontal?
I think that's more of a design question. I mean, like, you are able to render it in any kind of format. You can resize the canvas in whatever way you want, but it
Not like automatically like
yeah, I think that's like, let's say I'm building a shooter experience, right? I would probably want my players to play it in landscape mode. And for something else might probably be better in portrait mode, or you don't care. You can design your UI in a way that doesn't get in a way for either modes. Yeah.
Is like
Totally. Yeah, yeah. Yeah.
Just to make sure.
No, yeah. No, but I don't think this is particularly a WebXR thing. It's more of a web design. Yeah.
Okay, let's go to this side. Hands up with a question. All right.
Yeah, are you guys creating anything like the Meta Spark for XR experiences or for the Quest?
I unfortunately cannot comment on that. Right.
That, I know you're close to Spark, and I was hoping that you got those.
I'm sorry, I don't have any information to share on this. I'm sorry about that.
Will the default browser on the Quest support a web GPU standard?
We're working on it. Yeah, I believe that's the plan. Yeah.
Any more questions? Okay, coming back there. Thanks.
So I just saw in the presentation at the end that there's like controller tracking like whatever the inputs are. Is it similar? Like I think there's one more feature is like if you can track like where the person is looking at how the movement is, which is also like a very interesting feature in the XR community, like how the person interacts and where they're looking or something like that. Are we doing something for that?
You were talking about eye tracking specifically?
Yeah.
So the only device that supports eye tracking right now in Meta's lineup is the Quest Pro. And no, we're unfortunately not exposing that to WebXR at the moment for security concerns. I mean, WebXR is random websites, probably don't want people to have access to where you're looking at.
No, but on the developer side, was not, right?
I don't believe we have anything that will allow that at the moment.
All right, any more questions?
I just have a quick question on smart glasses. So is there any plan to like integrate the data that you get from smart glasses and use it for this kind of, data processing?
Smart glasses?
Yeah, like the very large smart glasses.
Ray-Ban smart glass. I don't believe it has any kind of
Because it's
capability
like,
for that.
Sounds,
Sorry?
it is by Meta.
It is. I don't believe there's any plan to do that. Yeah. Yeah, I can't comment on that. Sorry about that.
All right,
Thanks for the presentation.
Thank you.
Quick question is, building web app helps you skip the request store, but I guess you lose some moderation capabilities. Is that right?
I don't think, sorry, can you repeat your question real quick? I want to make sure I got the right thing.
If you build an app on web app, you skip the moderation, or you skip the heavier process like to get your app moved on the web store. So if you lose kind of moderation capabilities, do that?
Yeah, I think it's, yeah, it's correct to say that when you're not going through the quest store, you're not going through the moderation, but you also lose on marketing, right? You also lose on the exposure to people who are browsing in the quest store. So it's kind of a trade-off. I don't think that's a great motivation for, choosing WebXR to build stuff. I think WebXR and native XR have very distinct use cases. WebXR is more, I guess you can say short formed because, every time you're downloading everything, you can do some caching to help alleviate this process, but all the content you're basically being streamed from your web server to your local client. So it wouldn't be ideal if, let's say, you're building something like Asgard's Wrath in WebXR and people have to wait like 2 hours before before the web page loads. But it has uses elsewhere, like e-commerce websites, like pretty short form, right? Like a bite-sized experience, real estate huntings, things like that. I think it's more the use cases that differentiate the two instead of like the moderation process.
Okay, wait, my question was more on the security of the app store.
Well, it's just a website, so it's you can't do anything about like websites stuff. We do have a moderation process for like things that we feature on our new tab page, so if that helps. But yeah, it's the web, so.
Thanks so much for the presentation. I have a question about synthetic environment and when the XR plays in interest. I was wondering what type of the scenario that we're looking to, this is application. Is it consumer facing or is this business facing, and then is every customer can use it, or you collaborate on that?
Oh yeah, so this is a developer facing, it's a developer tool. So I mean, it's a developer facing feature, and I'd assume like if you want to build a mixed reality developer, you are a employee of a company, you wanted to, that's what you are focused on, building a mixed reality experience in a room environment, that's what you will use. I don't think this is consumer facing, if that helps. Yeah.
You mentioned the benefits from a developer perspective of developing on WebXR, the ability to update, push updates, and kind of reduce the friction. But from the trade-offs of being on WebXR, have your apps or have you seen other apps not be able to be discovered or have a discoverability issue because it's not on the meta store, or it's typing URLs, in VR is very difficult? Can you speak more to that?
Oh yeah, definitely. I think discoverability is definitely a challenge for developers, and well, I mean, it's on the web. There are other ways to promote something, especially if your app is cross-platform. You can host it in other things. Like there are a lot of let's say if you're building a web game, there are a lot of these kind of wouldn't say marketplaces, but it's a collection of web experiences that you can use to get traffic, and you can also upsell your XR capability inside your game. So that would be one way to do that. In terms of sorry, I lost my train of thought there. Oh, can you repeat your question? Sorry.
Top rated things, go on the website, which is great. It's not downloading the subscription, but then again, I have to type in a URL, which can be ours. So I'm curious if your experiences or other experiences.
Yeah. Sorry. That's a really good question, by the way. I think the first part of my answer hopefully helps. In terms of like reducing friction for users to get into the headset in WebXR, there are several ways to do that, right? One of the use cases that we're imagining is you're basically adding an XR capability to existing websites. Let's say Matterport is a great example. For example, this is a website that already works on your 2D screens. People already go there to actively do stuff, right? What you can do, we made it possible, is that we added a button that if you are visiting on a laptop and you have Meta logged, you logged into Facebook or something like that, and you can just click that button and that will send it to your headset. So the next time you're in headset, or you get into your headset right away, it's already waiting for you to be there. Yeah, so like I think bootstrapping this onto your existing web application is a great way to get traffic into WebXR.
Here. Thank you for the presentation.
Thank you.
I'm not going to put you in the spotlight to talk about install base or anything like that, but one of the things that we are thinking when it comes to WebXR is the capability for not only cross-platform, but only, forget about the headset, all due respect, how are you guys committed to real web developers from a back-end perspective to integrate the technology into a 2D world, at least right now, right? Or 3D experiences throughout the monitor and the future of the web, like really happening via that point. I don't have the intention to get political here. And again, I don't want you to talk to me about install base, but headsets right now, not a big deal yet. This is great, but games, what about the real future of the web from a back-end integration perspective?
Backend, as in
Like real integration, right? Like real integration with website experiences, with 2D environments, 3D environments in 2D, devices.
I actually struggle to understand this question. Like, I don't think there's a problem with integrating 3D content into 2D website today. Like a lot of websites do that already, right? Like you have React 3 that basically allows your React application to have 3D components in there very easily. 3JS is being used by a lot of different 2D websites that has 3D components in it. I don't think there's an issue there. I believe AWS also have some very exciting offerings in terms of doing a 3D asset pipeline to compress your model. And yeah, I mean, obviously I can say that we are not working on anything, like our team is not working on anything just because we are building the browser in the headset. This is not our focus, but yeah, it's been in my own experience, I don't think there is a huge issue there.
It was a good segue. Thank you. We do have someone here, Zachary from AWS. He and his team work closely with Meta on XR. And I think you guys are doing a lot of things also for community. So if you're interested in specific topics, I think, right?
Yeah.
Maybe just share a little bit what teams do.
I think a big effort between AWS and Meta is around uplifting the developer ecosystem within XR. So as a part of that, we're hosting hackathons and really thinking about ways to enable you all. So if you have any questions, want to learn more about what we're doing with Meta, happy to answer them. We're actually hosting a hackathon down in Palo Alto today and tomorrow as well as Thursday. I'm planning to do more. So any questions, feel free to come give us a holler.
Perfect. All right. Thanks so much, Felix.
Thank you.
Thank you.
There, echo? No echo.
I think I
Okay.
management of it. All right, so super excited for Mike to show us a little bit how AI is running its own code.
Yeah,
And my grammar check said it's without the, is that the spelling pattern?
it is.
It is, okay. All right, do that for Mike.
Thank you very much. Yes, hello everybody. Yes, so my name is Mike Chambers. I'm a developer advocate. I guess that bit's been done already. I'm not from around here. So I'm actually from Australia. I've recently flown in. So that means one thing, I am super jet lagged. So just bear with me and we'll see how we can make it through this session. You know a little bit about me. I'd like to know a little bit about you, and I'd like you to be able to see from each other as well. So who's building currently using generative AI inside of the application stack? Couple of hands going up, and who's willing to tell us about it? Okay, so a couple of hands going up. Maybe a subset of this, who's building agentic workflows and building using agents? Anyone building? A couple of positive hands going up, I like that. And a little bit, and maybe thinking about it, okay. All right, cool. That's cool. I want to talk about this overall, this topic of agentic code interpreter and AIs running code that they write themselves. Maybe the subtitle to this is what could possibly go wrong, and also how can we make sure that it's run safely. Let's see if this is working as it is. I want to jump straight into a demonstration here. I don't want to do lots of slides, but I do have some. Here's another question. Has anybody heard of this party rock? Is anybody strong here? Yes, strong here. There's some hands going up. Yes, cool, okay. For some of you in this room, it's going to be super useful. I think for some of you as well, this is going to be a very, very simple application, but it's useful for being able to show the wider audiences that you talk to as well about how generative AI works. And I just wanted to use it as a quick demo now. That you can't run code, the agentic code interpreter doesn't run in this, but I just want to use it as a sample. So, so this is Party Rock. It's a totally free service product, and it's built on top of Amazon Bedrock, and it allows you to be able to build, quickly build generative AI-based applications. So let's have a little bit of a play with it just very quickly. I'm going to click here at the top, right, let me know if this is not zoomed in enough. I'll click Generate App. What I'm actually able to do here is type in a prompt to describe an application, and that's then going to go ahead and build an app that itself then also uses generative AI. Just as a quick demo, let's type in here a day trip planner. Make sure I've spelled it all correctly, and I'll click Generate. So what's happening at the moment is it's taking that prompt and it's basically stripping it apart, doing prompt engineering stuff all behind the scenes, and it's building an application for us. So it's going to build hopefully an application which hopefully will be a day trip planner, and this application will itself use generative AI to help us plan our day trip. Okay, so this is what the interface looks like. So I have done this demo before, but I've never seen this specific application before. So let's see what it says. Okay, so up the top here, welcome to the day trip planner. It's got some introduction text. Then we've got these different boxes. So these boxes at the top here, the ones with the plain white top there, they're actually user input. So essentially from a development perspective, they're variables that we can assign. So let's have a go with it. So where's our starting location? I don't know, let's just say Cisco. Whoa, yes. I like that heckle. It's just spelling, not like you got it wrong. Francisco. Oh, for goodness sake. Yeah, that would probably work as well. Yes, yeah. Or Brisbane, Australia, or anything like that. Remember, jet lag, right? You're on my side. You're on my side, spelling person. Okay, interests and preferences. I don't know, food, generative AI. Yeah. Well, let's see what it does. Okay, and now I'm going to go and press the play button. Okay, so those are the inputs, and then we have this generative box at the bottom. This isn't the main thrust of what I wanted to talk about. but it's doing some generation. You've seen that kind of thing before. But what is happening here is that inside of the configuration for these boxes, we've got a prompt template. So just very briefly, if I go to the configuration for the starting location, it's basically got a widget title. That's the variable name. And then it's got some placeholder. You could have a default value. It chose not to create that for us in this particular case. The same would be here for interests and preferences. Now, in this box, if I go to edit, it's a little bit more interesting. So I get this prompt template. And so we can see here, it's written this for us. We could create it ourselves. We could go and modify this too, suggest some activities for a day trip from starting location, which of course is going to reference that. If I hover over it, it'll show us, based on the interests, blah, blah, blah. Let's see what it actually suggested. Oh, right, the AI exhibits at the Exploratorium. That's pretty good. Is that a good thing to go to? Yeah, should I do that while I'm here? Maybe, okay. Anyway, it comes up with a bunch of stuff, and then it's got its itinerary, which is another generated box down here. We could go ahead and change bits of this. I could do the thing that we always do, answer in the voice of the pirate. That's all generative AI demos, right? So hopefully if I run that again, then it's currently generating. Okay, so we'll see what the answer comes back with. That doesn't seem particularly piratish. Well, oh no, it's because I didn't save it. There we go. And then we can do some generation again. Anyway, so it's a free application which we can use to play around with building generative AI applications. And once this is finished generating the final thing, how far did it go? Oh, it's got a bunch of stuff it's been doing. So it's currently waiting on this. I don't know, maybe I'll give it a refresh in a minute. And the idea is that should come back with a pause. There we go. Okay. Oh, wait. All right. Okay. So it's come back with a pause. Not the key thing that I'm here to talk about. But it's a useful thing for being able to demo how to build these kind of applications. You can add more widgets in, you can do image widgets, and you can do all this kind of stuff. What I wanted to use this for was to begin this conversation about running code in the code interpreter, because I wanted to sort of explain the problem. And you probably know what this problem is already. I built this application here called the calculator. Actually, I didn't build it. Polyrock built it, but it did exactly what I wanted, which is to build a calculator that uses large language models. Now, intuitively, this is the wrong thing to do, right? Because large language models, they're language-based, they understand language, they don't understand maths. When I first started to look at this kind of thing, the first time I ever did code interpreter, or the predecessor to that, and working with LangChain and stuff, it was an absolute no-brainer. If you ask a large language model a mathematical question, it just failed the majority of the time. However, things have changed a bit, and actually large language models are deceptively good at doing maths. They still can't quite do it, but they can have a play. So if I say, just going to give it something super easy, so I don't know, 10 plus 10 plus 20 plus 3, I don't know, and then get rid of the M. I am looking at what I'm doing, and then press generate. So the prompt here is, yeah, okay, so we got it right. Okay, so it's using this sort of reasoning capability of the model actually to get it right. And I was experimenting away with this to try and figure out something that it would get wrong. And you start to do the square root of like large numbers. Let's say the square root of, and then I'll just type some, not make it too long. I don't have a calculator, right, ready, access. I suppose I kind of have on my phone. Maybe you could check that out. My guess is that that's probably not too far off. You're very good at maths. How's that? Is that good? Square root of 5,000 or something? Yeah. You don't like being put on the spot. So it figures it out, it reasons, and it actually gets an estimate of like not too bad. But the point is that it's not doing actual mathematics, right? Like the things that computers can actually do really well, it's not doing that. I'm going to go and, because I don't want to have to type this out by hand. This is another one of my favorites is to get the sum of a Fibonacci sequence up to a certain value, and I will put in a random value or slash in a keyboard value here, and we're going to press play, and we'll see what happens. Maybe, not sure. Certainly when I've done this in the past, it doesn't quite get it right. The point is that large language models use language, they don't use numbers. This isn't what they're designed to do. So how can we solve this problem? And it's the same kind of solution that we can use for any of these, well, a broad range of these sort of hallucination problems, because I guess that's essentially what's happening here, is it's hallucinating, and maybe it's hallucinating kind of right. But what do? Well, we introduce what we call these agentic workflows. So some of you have had a play with these. I just want to cover what agents are just briefly, so we can then go into a special kind of agent, which is what I want to show you. So if I just navigate back to my PowerPoint 1 second, I just want to show you this. Okay. Right. Yeah, walk down here a little bit. I feel like we need to give you some love, right? Like we're down here presenting. So what happens, what just happened then, right? And so we made this request and it went into the large language model. So large language models, as we've said, are language-based, but more than that, the only thing that a large language model knows is the language and the knowledge that it's been able to get through its training. So it has no connectivity to the outside world. So you ask it a question, such as, what am I going to do in San Francisco? And all of that information came from the time when the model was trained, and not from any current thing, like maybe that exhibition is closed, I don't know. So it doesn't have a connection to the outside world. So the way that we can fix this and give it a connection to the outside world so that it can actually be current, up to date, but also potentially do accurate mathematics for us, is to instead use an agent. And so the agent gives it a connection to the outside world. Now, I'll go into it in a little bit more detail than that. So what an agent actually is an application. It's a piece of code. It's not the large language model itself. It's a piece of code that can follow instructions, just like code can do. It can't think for itself. It can't reason or plan or problem solve. But what it can do is we can connect it to a large language model. And so now we have a piece of code that has a connection into the ability to do this kind of problem solving and natural language understanding. And so through that, we actually have an architecture which it can now connect to the outside world. And broadly speaking, outside of exactly what I'm going to talk about, in addition to what I'm talking about, the outside world looks like APIs, databases, knowledge bases, maybe a wiki that you have. So you can ask natural language questions of your agent, and it can then go and get authoritative truth, some facts from the data source, and use that rather than what it knows. And by the way, when I'm looking for a large language model, when I'm looking for the capabilities I want from a generative AI system, personally, I don't really want a large language model that thinks it knows all of these facts. Here's a fantastic one. I've been traveling around the world doing this one, and it lands slightly differently, but you'll probably get this. Who is the president of the United States of America? Right? Lots of people use that as a test question for a large language model. Now, if that model's been trained at the beginning of this year, it will be different at the end of this year, right? Because he's not standing. So it'll be someone else, or whenever it actually happens, maybe at the beginning of next year. So what I do want, though, is a large language model that knows what a president is, what the United States is, United States are, and also how to use external data sources to be able to go and find the actual answer that it needs. That's the basics of agentic workflow, and that's what I want the capability of the model to be working in conjunction with my agent. So I just want to talk briefly about the interactions here, because this is something that is a little tricky sometimes to get, especially if you've not used this kind of setup before. I just want to follow this through. So a request is made, so a natural language request is made of our agent. Now remember, our agent is just code. All it can do is follow instructions. So it doesn't know what that means. We're asking it a mathematical question, or we're asking it a factual question it doesn't know. But what it can do is it can send that question to the large language model, because the large language model does understand language. It can understand the nuance of what it's being asked. In addition to sending the request to the large language model, this green arrow that we've just drawn also includes all of the information about the data sources. So which data sources does this agent have access to, written in natural language provided to the model. So it might sound something like this. I want to know this, let's go for factual things for a moment. I want to know who the President of the United States is. By the way, I have access to an API to Wikipedia, through Wikipedia search. So at that point, LLM might think to itself, reason, think, and problem solve, and say, well, if that's what you want to know, and if that's the tool you've got, here are the instructions that I want you to follow. So specific structured data to say, well, go and call an API, and when you call that API, here are the variables that I want you to pass into the API. And the agent is a piece of code. It knows how to follow instructions, so it just goes and does that. So it will go call out to the data source. And of course, if any data source is available to you, if you can write code to connect to a data source, then you can connect to it using this agent workflow. And so then once it's made that call, obviously it's going to get some data back. Now we're at the same situation again. The agent has now got some data back. And yes, the data is kind of structured because it's going to be whatever it got back from the API or whatever it was calling. But it doesn't actually know if that answers the question that was being asked, right? So what do? Well, we send it back to the large language model. Now, the large language model, by the way, is completely stateless, so it doesn't remember that this is what we were talking about. So what we actually have to do under the hood is say, hey, large language model, this was my original question that I had, and this is what I could have done, and this is what you told me to go and do, so I went and did that, and this is the answer I got. And so the large language model can then analyze to see whether the information we got back from our data source actually answers the original question. And in this simple case, yes, it did. So it's going to respond and say, okay, this is the answer that you can go and give back to the requester. So the requester makes this request in natural language and ultimately gets a response in natural language. And all of this stuff happened in the background. And I have to hurry up. So this kind of architecture is used for multiple kinds of agentic workflow. In fact, this is the agentic workflow. So you may have heard of things like retrieval augmented generation. There's more to it, but it basically does the same thing. We've got function calling, which is basically calling an API and going and doing something like that. And we've got just one-time execution of code, which is really what I want to demonstrate to you today. What happens if we have a natural language query that looks a bit like this? Well, as I've already explained, the models are doing pretty well at trying to do stuff like this. We can probably get it right. But my point is, we can't rely on it. And look, in reality, I've only made 3 sales, so I'm not doing particularly well. Imagine this list is much longer than this, and we want to add up much more data. How can we get around this? Well, back to this briefly, we're going to use this architecture, but this time the large language model will say, well, I've written some Python, I've written some code for you, go run this code. And then when you've got the answer to that, then that's the answer from that agentic workflow. So they can go back to the large language model and see where it got it right. By the way, and any developers in the room, it's not particularly pretty, that code. It doesn't look very reusable, that code, and it's not intended to be. It's only run once. Once it's run, essentially, we just throw it away. The model has written the code to answer the question, and now we've got our answer back. Now, before I just jump into a quick demo, I just want to show you some of the things this can do, because I think it's really cool, and I get very excited about it. This is something you've been able to do for a little while. There are other tools out there which will help you do this. LangChain has had the Python REPL library for some time. I've experimented with this, but there is one massive thing in the middle of their own web page even, and I really want you to look at this. So this is something you need to do with your eyes open. So we talked about hallucination, we've talked about the way that these models are sort of just generating whatever. Imagine that it's just happens to generate code that you really don't want to run on your own laptop because it says, I don't know, delete star or something bad like that. You don't want that, I don't want that. So actually how you apply security around this is super important. And so there are services out there which basically have secure container sandbox environments specifically for the purpose of running code which is being generated by a large language model. So let's have a look at that in action. I'll show you really briefly here inside of the Amazon console page. Hopefully this is familiar territory to some of you, but Amazon Bedrock is the service which has a bunch of different foundation models so that you can easily integrate those into your application. So things like Anthropic's Claude models are in there, Mistral AI models are in there. There's a whole list. It gets bigger all the time. But apart from that, not just those foundation models available, we also have these managed capabilities in there as well, such as that agentic workflow that I showed you. So if I just really quickly go in here and go down the menu on the left-hand side to agents, I've got a few different agents in here, but I'm going to go to this data processor agent, and I want to show you this working in just a sec. But basically, you can build up that agentic architecture that I showed you. If I just go into, I'm going to edit one that already exists rather than create a new one. So you've got some configuration options here, what you want to call the thing, the description, all that kind of stuff. And then here we've got model selection. So that little line that went up to choose a large language model, that's what this is. And you get to choose one of the models that's available on Amazon Bedrock. You get to do some prompting. I've got myself a nice, massive, big system prompt here to talk about how to do things like code execution ideas. So not specifically how to write code, but how to think whilst you're planning out writing code. So some good advice. I can test this a lot more than I've done here, but I actually got Claude itself to write this for itself. You know, I asked it what would it prompt itself in this circumstance. And then all we have to do in this particular setup is underneath additional settings is we just enable that. I was talking to someone ahead of this, and we were talking about what they did and what I was doing, and what I was talking about. And I said, I'm going to be showing code interpreter. And they were like, I think I said just code interpreter. And they said, wow, that sounds like a lot. All I did was click that radio button and hit save. Unfortunately, it's that simple. But basically what that means is that the agent now has access to this code interpreter environment and will send queries that are required for things like mathematical execution. It will send it off to this agent. Let me show you this in action if everything goes my way. So let's have a go back. In fact, what I'm going to do here is I'm going to go and grab this, which was the query that we were working on before. I'm going to try and get rid of how do I help? Okay, there we go. So this is a simple chatbot interface. It's very simple, but it basically is using that agent that I just showed you with the code interpreter in the background. I'm going to paste this in and I'm going to click send. Now, one thing that's not going to happen immediately is we're going to have lots of text generated. Typically, when we're using an agent, that text is being generated in the background, but it's doing all of that reasoning flow and all of that API calls and all that kind of stuff. So it goes faster than I'm talking, but we eventually get this answer as one block. And that should be the right answer. Now, what I can do here is I can turn on what I call debug. It's actually called trace inside of the application. Just going to reset that and press play again. This time, what we'll be able to do is we'll actually be able to see all of that conversation which was happening in the background. So this natural language that we're looking here, it goes very quickly. This natural language that we're looking at here is actually text that the agent is sending to itself. So to calculate the sum of the Fibonacci sequence, I will need to go and do blah, blah, blah. And then we can see some Python code which is being generated here, and then we get the response of that. It's actually doing it in two different steps. So it's generated the sequence, and now it's going to go ahead and write some more Python code to go and add that sequence together. And then this is why I didn't put it to screen initially, because it looks like a lot of nonsense, but then it comes out with the answer like that. And so it's actually running this code on top of that code platform. Just a couple more things before I get dragged off stage. Let's go and reset that. I can also add in some data sources. So for those of you who have done any kind of machine learning study and like figured out how to train models, one of the data sets that you play around with is the California house price data set, right? Well, I've just put it in here. Now, if we had a little bit longer, I could probably type in here, train a machine learning model on this data. It sometimes works. I'll be honest with you, it doesn't always work in my simple demo here. But let's say this, let's say map this data. I love that prompt because it's super short and I spelled it right. Basically that's all I've told this execution environment is here is the complete California house price data, and I've asked it to map it. I haven't told it anything about the data. I haven't told it about if there is anything in there which is even mappable. Now it might sometimes, as it's going through here, actually come up with some errors. And so sometimes an error might occur and it will see that error and say, right, I need to do it a different way. And it will problem solve and it will go through. So yeah, it's come up with an error there. That's not that surprising, but you know, if the demo gods on my side, then it will eventually come out with, there we go, a map. It's done a fantastic job. So yeah, look, it's simple. Okay, debug. Spun out there. So that's a map of California with the house pricing data. So if I can show you that data really quickly, where is it? It's on my desktop because that's where all data should be. So if I just preview the data, it's gone into here and can I zoom in? No, not really. So I've got latitude and longitude in the first column. It's figured that out. It's looked at it and it's gone, okay, well, the median house price is probably what you want, which is the coloration that is put on that graph. Some pretty awesome stuff. Now, if you want to have a go with this, then I've got a couple of notebooks in this repository that actually take you all the way through the process of creating an agent and then deploying the agent, testing the agent, and then tearing it down as well. I see some people taking pictures of this. What we need is a QR code. So let's go over to this. Let's go reset on this and say, create a QR code for this. I've not told it anything about QR codes. I haven't given it any kind of special prompts or anything, but it knows how to write Python. And so with any luck, but yeah, it's gone through some debug, we've got a QR code. And this is where you get to test it for me and see if that QR code goes to that repository. Fingers crossed that it does. And someone gives me a thumbs up.
Yes.
Hey. Thank you so much. Look, whistle stop tour. I'll be hanging around somewhere with my laptop. I think I'm going to get to go stage here. I just wanted to show you how you could use that agentic workflow to then connect into authoritative truth and how that authoritative truth can be something you can generate on the fly. It can run code for you on the fly. Thank you so much for your time and attention. Really appreciate it. Thank you.
All right. And while Danilo can set up, do we have
question is specific for the not specific for code development. Yes. So methodology is very important, right? You are obviously doing LLM and data source API. And then the members say the doings. Yeah. So how we can draw a line that what is the layer of that when I should go ahead with an agent, I should go ahead with the same the tools. Yeah. That's a good question. So for context, for broader context here, one of the ways that you can use foundation models in LLMs and Bedrock is you can just call them directly, and you can get pretty much raw access to the model, which can be super powerful. But it can also just add a little bit more complexity. So another way you can do it is to use the Converse API, which basically gives you the user assistant kind of data structure flow, which helps, I guess, with the structuring of that conversation. For everyone's context, agents doesn't do that. So agents basically is essentially a managed chatbot. And so you have now an option about which way you go. And also with some of the models, you can do tool use, and so you can do that as well. In terms of differentiating between the two, I'm a big fan of using managed services out of the box if they provide you with what you want. And agents
Amazon Bedrock Agents provides that completely out of the box. You've got basically that it ties back to scale, so you can back it onto Lambda functions. In this particular case, it goes back into the service. So it's an endpoint basis service where you can really quickly and rapidly get to something in production. Then if you find that it's not gone far enough, A, give us feedback. We want to know that. B, you've got other options where you can go and do your own stuff if you want. But at that point, you're going to have to figure out where some of that stuff's going to get hosted. So where's the code and logic? Yeah.
Any question over there?
Yeah.
I wanted to ask you about, so, whether thank you so much. To ask about, so if the agentic framework has been just right now, what do you see as the main problems that it's running into, and how are you or any of your doing about solving?
Okay. Just a small question. Yeah, so you're talking about agentic workflow frameworks generally. Yeah. So I think one of the general problems, which I think actually happens to be something that they do quite well, is hosting a scale and getting to production. So last year was the year when I was very happy to spend all of my time inside the Jupyter notebook, and I was like going, look what I can do here. Isn't that cool? So I had all kinds of vendor code running on my laptop. But now we need to figure out the production scale, security, the ops side of things. That's something we need to figure out. And so I think that the agents and how that's going to be integrated into that is a big part of that. I think more broadly speaking than that, look, it's just such an active area of development. Multi-agentic workflows is a massive thing at the moment. So getting different agents for different personalities to do different aspects of jobs. That's still a thing that I think we're figuring out exactly how that's going to look. There's definitely some things out there like Flu AI. We have flow, so we actually have a flow orchestration thing. You can bring multiple agents together, and yeah, I think it's a huge question. There's a tiny answer.
That's great, thank you. You mentioned agentic workflows. My question is there connected with a vision model? That you got that?
Yeah.
So you can make
yeah, no, absolutely. So one of the things that AWS is really good at is sort of what I call Lego block building blocks, so you can basically build everything. So one of the things that went into public preview a month or so ago was what I was just saying there with flows. So prompt flows is called, and prompt flows allow you to be able to connect together different agents, simpler things in agents, prompts, also Lambda functions, and it's in AWS land, if the question is, can I do? The answer is almost always yes, because you've got a Lambda function. So you can set it up. So you can bolt those in too, and then you can have that going off to all kinds of other things. So I have got agents that call out to other generative processes, where so the tool in that case is another generative process, and the original agent is none the wiser to know. It just calls it, and it knows how to call it, and it happens to be that next process is a generative process. So yeah, it's all there to be manipulated and plugged in whichever way you want. So it's totally cool.
Hi, thank you, Mike, for an excellent presentation. Great stuff. I have a simple question. Can we are using this page and see like currency? It'll see like confirmation. Someone.
Yes.
Cool.
Thank you. Yeah. So confirmation can deploy. You can also use things like CDK and SAP. Some of the newer stuff won't necessarily be always supported day zero, but yes.
Okay, let's do one more question and we have to get going, but Mike will be here if you have questions after the next one as well.
It's getting to the point where like I did chat has gone the opposite way, but now it's basically lunchtime. So
Okay, one more question.
Thank you very much for the presentation. Excuse me if I missed it, I need to calculate, but on Amazon Bedrock, do you provide both the instructs and the base models, or not? Because I know that the base model can be very interesting when you want to fine tune, basically. and makes it more flexibility to the user. So I'm just always curious if that's something more.
Yeah, so Bedrock focuses on instruct models. It does give you the ability to do some fine tuning inside of Bedrock, so there is that access. If you're interested in taking, did I say instruct models? If you're interested in taking the base models, then you've got things like SageMaker. And so SageMaker is probably where you want to go because you can pretty much bring any model in at that point and train further from there. So yeah, and then you can potentially, depending on a bunch of stuff, import that model then into Bedrock. So
And really quickly, the last one is what about like ES16 versus like games? How does it work?
So Amazon Bedrock really just abstracts you away from all of that stuff, right? So basically it's giving you an API so that you can go and call it because you're an AI engineer and you just want to start extracting value from your business data. If you want to get down to that level, SageMaker is your friend.
Thanks so much for that. Much more than
I know the difference.
And now I'm excited to welcome Danilo on stage. Danilo is also visiting us, including from the UK. So another one with a little bit of January.
Yes.
So thanks for sticking around. And Danilo, you will talk about beyond text. So you're putting all the cool components together, right? Like
Yeah.
interface, multi-modal, right? A lot of good stuff coming here.
I hope so. I hope so.
Okay.
Yeah. Thank you. So thanks for staying. I'm the second jet lag speaker of the evening. It's the middle of the night for my body. So I hope I will
Your screen, sorry. So
yeah. Sorry, we have this set up. Share. Okay.
gotcha.
And now I can't remove this.
Yeah.
That's the minimum. Okay. Okay, so sorry for the interruption. So as many of you, I'm passionate about this chat interface with these powerful models, but sometimes I get frustrated with the limitations, like it was already mentioned, the data is not updated. Maybe I want to manage different modality like images and text together. I want to run computation. So I ran this experiment. I wanted to build something that goes beyond the pure text interface of the traditional chat. So we will add a little bit of theory at the beginning, then I will go through a few demos, and during the demo, we will see the code that is part of my experiment. So when we want to go beyond text, we need a way to represent these things for models. Machine learning models, they only understand numbers. So we need to use embeddings. Probably many of you are familiar with embeddings, but embeddings are vectors, so a long series of numbers that represents the data that we want in a vector space, so in a different space. And this vector captures the meaning of these things that we translate into vectors and the relationship. So normally we start from something that is very high dimensional, like words or images, and we want to transform this object into something that is more manageable. So a lower dimensional space. The examples that we do today use 1024 dimensions, so 1024 numbers in a -1 +1 interval for each number. And the idea is that when we transform different concepts into this space, we want to preserve similarity and relationship. So similar things will go into similar and closer numbers in this space. When we go multimodal, then we need to have a shared vector space where we have numbers that represents maybe images and other numbers represents numbers. And again, I want similarity to work into this shared space. And in this way, we are able to reason about text and images, for example, in a similar way. So let's do a quick example. So in text embedding, I said we normally have maybe 1000 dimensions. Here is a simplification in 2 dimensions. Maybe I have the word queen and the word king. They're probably not far apart because they represent similar concepts, but there is some distance. And if I take the concept, the word of woman and the word man, probably the distance between queen and king and woman and man in this vector space is similar because this the difference between similar concepts is preserved as part of the relationship. And if I add images, I expect the images of queen, kings, woman, and man to be in a similar position and not too far away in this vector space. There's a lot of challenges, and the main challenges is imbalance. So if I start to mix words and images, for example, I need to find a way where this data is balanced so that I don't have one modality like images or text to prevail on the other modality, and then the vector space is unbalanced and doesn't work well. I need to handle overfitting modalities. So maybe my model it's fitting very well images, but the text is not. So I need maybe to add regularization and balance the results. I need to handle missing modalities. Maybe I have a lot of words, a lot of images, but I don't have the same numbers, and maybe for some concept I have only the words and not the images. So maybe I need to use a generative approach to generate the missing data to rebalance the data set. Or maybe I can try to build a network that is more resistant to this missing data. So I can use maybe dropouts. So I just drop out a full modality for some iteration of the training so that the training is more robust to this missing data. One of the techniques that is very popular because it's very simple to use and you can run it also on your laptop if you want is contrastive learning. So the idea is we start with two different embedding models, maybe one for text and one for images. And then we create a single vector space, but we can just copy the numbers there because when they were trained, the same concept maybe went into different numbers. So we need to provide contrastive examples that help us rebalance these weights. So basically you start with an anchor that is a starting point for a concept, maybe a text or an image. Then I provide a positive example, so something that I want to get closer to, and a negative example, something that I want to get far away. So for example, I have an image of a plane. You can imagine I was flying yesterday, so that was the idea. And if I have other images of plane or short sentences that talks about planes, I want to get this closer to me, while maybe a picture of an insect or a sentence that talks about insects, that should be put away. And if I continuously iterate with this approach, with the two data sets that are merged into the same vector space, this vector space will self-organize so that the similar concept will get together and different concept will get farther away. So that's a very simple, interesting approach. So using this technology is what I try to build. So I try to build a multimodal chat. So I use Amazon Bedrock to provide the foundational model. As main model, I use Claude 3.5 Sonnet. But because I use the Converse API of Bedrock, I can very easily switch from one model to another because I just need to change the model ID and the syntax with user assistance sentences is preserved. And then I use, for embedding, Amazon Titan, and I use both a text embedding and a multimodal embedding, and we'll come shortly to see why I did that. Then I enable tool use. So basically, I can describe a series of tools to the model and say, hey, if you need, you can use these tools to download images, to download content from the internet, to do computation, and so on. To store the vectors in the vector spaces, I used OpenSearch. OpenSearch, I actually run it locally here on this laptop, but you can use a managed version if you want. And the reason why I use two embeddings and two indexes is that when we do multimodal embeddings, there's this problem of balance. So the amount of information that we can extract from an image and the amount of information that we can put inside a sentence of text needs to be balanced. So normally you can't have too much text because otherwise it brings too much information compared to an image. So normally multimodal embeddings, they don't allow too much text when you ask to embed a sentence. So for example, they normally are in the range of the 100 tokens, so basically less than 100 words. And this doesn't work very well with long text. So that's why I use the text embedding for long text, and then the multimodal embedding for images and description of the images that is a short text. And these are stored into OpenSearch. And then I use Gradio for the web interface, not the open source framework. So if we go here into the code, there is this JSON file here that is where I describe the tools. And basically I have a syntax when I gave the name of the tool, I call this tool Python, and you can use this tool. This description is passed to the model. You can use this tool to run a Python script. the LLM doesn't know how this tool works. It knows that if it wants to run Python code, it can use this tool. And then using JSON schema, I can tell to the model how to use this tool. So I need one property that is called script. It's required, and it's the Python script that I want to run, and so on. If we go into the code, this is the chat interface provided by Gradio. So it's basically all the web interface is done for me. And then I need to pass a chat function that will get the input message and provide the response. If we go into the chat function, I basically have two steps here. The first step takes the message in the syntax of Gradio and translates that to the syntax of Bedrock for the Converse API. And then the second part is I run these messages in a loop. So I was arguing with Mike if this is an agent or not. I don't have any agentic workflow here. I just have a loop on the tools. So what I do is I invoke the text model with these messages. So the first time there will be a message, then there's the history of the conversation. As I invoke the model knows the tools that it can use. So in the response, it can include the request to use a tool, like, oh, to answer this question, I would like to run this Python script, or I want to search the web. This handle response function will look into that, and if you see there is a tool use content block in the answer, we'll get the tool result. And if I go here, this tool result is actually calling a function that depends on the name of the tool. And if I go here, we get the list of the tool functions. And this is mapping the name of the tool as in the JSON file with the corresponding function that runs that code. So there is a Python to run Python. I can interact with to search the web. I use DuckDuckGo because it doesn't require any API key. So I'll share the code at the end and you can run it without having to put any specific API key. I can search the web, the news and maps with DuckDuckGo. I can search and download Wikipedia pages. I can browse the internet using Selenium to simulate a browser. I wanted to give a random access storage. So when you download a web page, normally you can get 20, 30,000 words. It's too much, and also it's expensive to pass everything to the model for reasoning on this data. So I store the result of a web page into an archive that is basically similar to a RAG model where I chunk the text. And then I give this tool to the model that says, okay, if you search, now that you have the content, search using keyword into your local store, and it only grab the information that you need. So instead of 30K tokens, I can get maybe 1/5 of that. And then I have other tools that we can see maybe in the live demo. So let's start and see how that works. So first, I want to show how to browse the internet and archive data. So I want to browse the internet using Selenium, and then I want to use the text archive to archive documents and retrieve the documents by words. So I start, I hope you can see it. I couldn't zoom it too much. So I start and I ask, can you compare Amazon Bedrock and Amazon SageMaker? Look at their product pages. So instead of a baked result, it will actually look at the pages now, or maybe yesterday we have on the demo. And if there's new features, it will download them. So it's just downloading the pages, chunking the pages in 800 characters each, indexing these pages into the text vector index. And then it's automatically the model in the loop using the retrieve from archive tool to ask questions like, give me all the information on Amazon Bedrock, purpose, main, focus, and the same for Amazon SageMaker. Only this information is retrieved, passed back to the model, and the model says, okay, now I have enough information, and I will reply. And this is the quite detailed replay that compares Bedrock, that is providing you a high-level API to access the foundational model, to SageMaker that can help you train and up to deploy the model. So it's targeting slightly different use cases. Instead of passing all the information, the model is retrieving the information from the storage. Now let's go multimodal. So in this case, I store images on a local file system, and then I create an image catalog using this vector index. I can then retrieve images by text description. and this will go on the text part of the multimodal index, or I can retrieve images by similarity with other images using the image part of the multimodal index. I can also retrieve random images using the fact that because images are indexed in a vector space, if I use random numbers, I can get random images very quickly. And then you can download also images from the web. So in this case, I started ask, what can you do with images? And now the model will just look at the tools and tell me, okay, based on the tools, I can search for images, I can find similar images, I can get random images, download images, and so on. So now let's pass a few images that I have here on the hard drive, and I just ask to compare these images. This is something that you can do directly with the model, but as the images are uploaded, they are also indexed by this chatbot. So what it's doing is actually storing the images locally and then performing the multimodal embedding and indexing each image for future use. So at the end, I get the standard response from the model that says, oh, nice, this is a series of pictures of dogs and cats, and then it's doing all the comparison. And on the right, you see all the information of the retrieved images. So now I can ask questions. So I clear the context just to avoid that, because otherwise the model already knows all the images. And I can say, find an image of a dog. And this is the result from the multimodal index. And if you look, it's more here, unfortunately. When you search into a multimodal index and you search for any concept, you're just doing similarity search. So if I search for a spaceship, there's no spaceship in my index now, but it will still list the nearest point to the concept of spaceship. So what I have is a filter. After the first 5 images are selected, it will look at the text description and my request and filter the result to take only those that make sense. In this case, out of the 5 that were shown, only 4 images were shown. And if you go here, you see that the last, so the farthest away for the index was an image of a cat, because a cat is still similar to a dog. So if I do similarity, the first result starts to be away from my initial request. So I do similarity search on the multimodal index plus a filter on the description. I can also use the same approach to generate images. And the idea here is that I can generate images not by just giving a prompt, but by giving a full conversation. So to start, I can say, generate the image of a dog on a bike and also of a cat driving a fast car. Now it's going to use the Titan image generator model that was mentioned before, and then it will index and store the images locally. And for each image here, you will see the model will generate a prompt to generate the image, starting from my initial request. And then it will generate the image, and then it will generate a description of the image from that image itself that is slightly different from the initial prompt because it's more detailed. So now I have 2 more images, and I can say, find an image with a car, for example. And now there is a car, but it is only 1 image. So of all of these results, from the 5 images, only 1 is filtered out, and it's the only image with a car, because the other one were just close in the space, in the vector space, but not relevant for this result. I can ask how many images are in this catalog, and it will just use the OpenSearch API to get the number of 10 images. And then I can say, show me a random image. So showing me a random image is actually taking a random point, the vector space, and taking the closest image. And actually, when I recorded this, it gave me just the image that I generated. And I can now say, now find an image similar to this one. And now I'm using the multimodal filter index to do similarity search. And when you do similarity, I have to discount the first result, because since the original image was in the database, the first one is score 1, it's the same image. The second image is the closest one. Let's do it again, because this was not really great. So I ask for another random image. This time I have this nice running dog. Now I ask for to find 2 images that are similar to this one. And it's actually changing the parameters. So it's now taking 3, squatting the first one because it's the same image as there, and turning the other 2 similarly image. And this is similarity. So you cannot filter on results. So it could, for example, maybe give you a cat in a similar pose. So the next step was to add in compute environment. Running code generated by the model is always risky. So what I did was to use an AWS Lambda function. So when you have an AWS Lambda function, you have a micro VM in the cloud, and you can give AWS permissions. In this case, I removed all permissions. I left the permission to write logs, but in theory, you can remove that one as well. And then I created a container image that is used to run this code, and there is a separate requirement.txt where I can add all the modules that I want this the code to have access to, like NumPy, Pandas, and so on. This is Python only, but could be extended to other platforms. And for example, let's start. So how many prime numbers are between 1 and 10, 1 and 100, and so on, up to 1 million? So it's a very nerdy question. It's now generating the program. Prime, then to test the number if it's separate, then it counts the prime, the result, and then passing back the result to the model that will describe the result with a lot of words. And at the end, I attach the Python script and the output from the model, from the computational environment. Now let's do something a little bit more complex, like give me 10 triangles where at least one side is a right triangle, so at least one side is a prime number. And it generated this program very quickly. And in this case, when we go and see the program, there's a little bit more of a search function. So we basically have it generated a function to test for prime numbers and another function to search the space of possible numbers that are right triangles, and also one of the numbers is prime. Another thing that I always struggle is this asymmetry between how much data we can give in input, normally hundreds of thousands of tokens of words, and the output that you can get from an invocation is normally much smaller, in the range of the thousands. And after 1,000 tokens, the quality of the output starts to degrade. So I said, let's give another tool that is a sequential storage. So I tell to the model in the tool, you have access to a notebook. You can write pages each at a time. And when you finish, you tell me and you give me the full notebook with all the pages. So it's an abstraction that the model understands very well. And also I give the idea of a review. So if you want, you can review all the pages sequentially and maybe update the pages as you do that. You can check the overall length. So I can say, write a document of 10,000 words, and the model can check that the length is correct. And in theory, in this way, you can write a full book because there's no limit in the output. And it's also efficient because it works with small chunks at a time. So I start and say, you're a machine learning expert, write a 5-page article explaining multimodal embeddings and how they are trained to an audience of software engineering. Look for recent articles from the last couple of years. So it's start to write the index and then write the single pages. So at the beginning, it was searching the internet, and now it's writing all the pages. This is, of course, accelerated. And then it's doing the review of all the pages. Because I didn't give precise instructions for the review, it didn't change anything. So I just look at all the pages and say, oh, I have a lot of things, I don't need to update them. And then it's sending me this very, very long article, much longer than what I can get normally from a model. In theory, I can do very, very long stuff in this way. But I noticed that the code maybe was not correct. So I can say something like, run the code. I'm sorry, before I do that, I can also save it. So I can say save it, and it will write the code on a file, and I can then read it. Read it on this way. What I can do more is that I can force a nice review where I update each page. So in this case, what I'm going to do, I can say, write an article about computing pi with numerical methods in Python. I've always been maybe such an nerd to be fascinated by pi. I read the contact book by Zhang. If you didn't, it's a very interesting science fiction book. And at the end, the number pi has a very important part in the story. So it's looking into different ways to compute pi, sort of Monte Carlo methods where you throw random numbers and then you count how many are inside a circle, to very advanced algorithms. It's writing, again, a very long piece of content, but I'm not sure that all this code is correct. So now I can do something more. In fact, if I look here, I think you see there's some errors here and there that are in the output. Sometimes it forgets to import the same module again and again because it doesn't understand that every time it's run in a separate environment. So it does this kind of mistakes. So what I can do, I can ask to do a review and check the code, run the code, and update the article with the right results. So it's just looking at the output here, and I can ask, can you run and test all code snippets and then add the output that you get to the article? So it's now starting a review. I just introduced the concept of review. The model is understanding how we use it, and it's just on the piece of code, seeing if there are errors, taking the output and updating the notebook page by page with the result. And in this way, we get something that it's been tested and it's been updated. So this is an example of a review that it's quite interesting. At the end is sharing the notebook, and now we're getting more safer code with good result, and I can save it again with and use it. So some thoughts. Streaming is not implemented. So as Mike mentioned, streaming normally doesn't work very well with agents, but the Bedrock Converse API supports streaming. So what you would get is a sort of stream of consciousness of the model telling you what it's doing. It could be fun. All the functionalities that we saw is in a chatbot, but it's a single function call, the run loop that I showed at the beginning. So if you want to incorporate this into your application, maybe you want to have an application that every morning reads your emails and writes you a to-do list of the things that you want to do, you can just take this code and maybe add one tool to access your email, and that's it. You can reuse it 95% of the lines. One thing that I would like to add is that as it's browsing internet, it's only taking text. Maybe you can download the images and put them in the catalog and index them. So it could be interesting. So if you'd like to play a little bit more with it, I pre-generated the QR code because I didn't want to test these functionalities. But yeah, this is the code. It's on GitHub. Happy to get your feedback and to see if it can be useful also for you. And thank you. Let me know on X, Twitter, LinkedIn, whatever, what you think. Thanks.
Right. We do have time if people have questions, but I also want to say this wraps up the official program for the day. So thank you very much, everyone who joined us tonight. Really appreciate your coming here, taking the time out of your day. Appreciate all of you who are still here. I know it has been like 2 hours of talks and demos. I hope you learned something. Let us know. Also make sure to scan the back of the badge for more events coming up. We have a mix of like meetups, we have workshops coming up. So really keep checking, we keep adding events there. And with that, let's go to the question. I think somewhere is saying Mike, we lost 200. We got your mics over there.
Well, thank you for such a wonderful thing. That you
first, I'm not questioning that it's retrieval file. So whenever you're asking the questions to the chat, it is able to retrieve the images related to it. So that means, are you also embedding the images in some place that you're retrieving those? Like how
Yes. So there is a interpret, there is a store image program that is storing, it's computing a unique ID, like a hash code of the byte of the file, storing the image. It also reduce the size to avoid the limits that there are in different APIs to us on the multi-level. Then I generate a text description using the model with the temperature 0, so there is a very dry description of the image. Then I use the multi-modal embedding with the image content and the textual description, and then I store that into the multi-modal index. And the fun part is that the multi-modal index and the text index are exactly the same for the search. So when you go multi-modal, actually, the problem is the embedding. For the database, it's just a lot of numbers. I need to keep them separated because I didn't have the possibility to merge the two spaces for similarity, but it's just similarity search. One is an algorithm with a 70 years of life.
It's not the last question. But when you say similarity, usually the thing that comes into our mind is protecting. Are there any other things that you would separately or?
So for the vector space, it's constant similarity always for text and then multimodal index. What I added is if I do similarity with images, I just similarity with the images. If I do set by description, it's using the multimodal index, but then I fill the results as I show because it can bring something that is close. So especially the first view, you can get results that are not correct. So I added a second filter to do that. And the filter is using the textual description.
Thank you so much.
You're welcome.
All right, who else has questions? You have, yeah. Please.
Thank you very much. Presentation. My question is, what do you use?
In the filter for the images, I use again the translate model. I use Sonnet 3.5. It probably don't need that much power. Zero temperature. So and I ask based on this description, filter only the images that are compatible with this description. Output JSON and nothing else.
You do a model based.
Yes.
Visualization of the results.
Yes. So for this kind of things that you add a certain layer, I normally go zero temperature and very dry questions.
Yeah, thank you again for all of this. Wanted to ask also, I like these short bite-sized demos, but I wanted to also ask what kind of real world production use cases have you seen or you find particularly interesting?
So as I said, here it starts on the chat interface, but you have this iteration of two users that can do a lot of things. So normally what I see is when you need to compare different data sources and the same kind of information. One very strange example I've seen recently is in the IoT space. So apparently they are collecting information from sensors. I think this is based on a few countries in Africa. They have so many different versions of firmware sensors. It was impossible to track all of them. Then they use a model like this to make it simple to reconcile the data because a human would be able to do that. These agents are able to do that.
Interesting. So taking in all of the data, all these different sources.
With a lot of different formats, maybe some of JSON, some of different. And then the model is translating all these formats into a standard format, something that if you think a human with a handbook probably can do, but with a traditional approach, you would need to have all the possible syntaxes, all the possible revisions, and this was impossible for their project. So they can merge all this information very easily. So this is an interesting thing. So merging different data sources where you don't have control of all the possible syntax.
Thank you so much.
Obviously, for a great presentation. And it's a great question. So actually, So the vector search, I believe was
It's KNN, so it's put in place KNN. They use some tuning that I have to admit were passed to me to optimize the results. So I didn't enter too much into that part. But other than that, it's just getting the nearest neighbor in the vector space. For description, I added the second layer of filtering because, as I said, if you search for an alien, it will, even if there is no picture, it will tell you which are the nearest image to the concept of an alien in the space.
Also, in the implementation, you have an option to kind of define answer in terms of predictive model. Get back to you, taking more time, but having more accurate information.
So in this case, no, similar research is not handled by the model, no, it's handled by the vector database. And that part is pure nearest neighbor search.
Yeah.
So there are these points that represent concepts and or pieces of content, to just tell you which are near the space. You need to add a second layer. Normally in RAG, you have the concept of re-ranking, where you get the chunks from the rank system, then you rank and filter. So it's a sort of implementation of the ranking for this specific use case. Make sense?
We have the last question. And then you mentioned now empty devices, so there's a lot of empty devices. Communication protocols. So I guess how do you monopolize this data and use it for your implementation?
Yeah, so this use case it's based on a few countries in Africa where they wanted to collect information from the environment, and they have the most disparate different devices like visions. So it was really impossible for them to do a classical approach of, okay, this is all the formats that need to be translated. So I like this approach because it's really using the outside the human side of this model. So the fact that they can take anything, reason on that data and put it into a standard format.
Thank you.
You're welcome.
More questions? This is it. Thanks so much again for coming up.
Thank you for staying.
Anything like most of the speakers, definitely all here, there's videos here, we have our social media platform of your choice, but mostly I think LinkedIn, Twitter. So feel free to connect with us, feel free to come again. My team here, we're hosting another event on Thursday night. With Antje on my stage. And yeah, look forward to seeing you on next year. Thank you.
Thank you.
Just,
Good job. Still holding up.
And you closed the
I did.
went to sleep.